In this lesson, we're going to examine another algebraic way for solving a system of equations. So at the end of the lesson, you should be able to answer, how do I solve a system of equations using elimination? This method is also referred to as linear combination. All right, here's the big idea. It's called elimination because your goal is to eliminate one of the variables and create an equation that's all in either just x or all y. In order to do this, you want to create a pair of opposite terms. There's multiple ways of doing this specific system, but I observe that my y's have the same coefficient. They both have positive 1. If they were opposites, I'd be in great shape, meaning one's positive 1 and the other is negative 1. So I'm going to cause that to happen by multiplying. If I multiply this bottom equation by negative 1, that will produce an equation that would be negative 2x minus y equals positive 4. I'm just going to recopy the top equation because I'm stacking them. And now that I've created a pair of opposites, I'm going to add these two equations together. 3x plus negative 2x is 1x. Y plus negative y is 0, so that variable is eliminated. And 6 and 4 is 10. I'm halfway there. I know that these two lines will intersect at x equals 10. I have to figure out the y value. So this is the final step, which is to substitute 10 into one of the equations. I'm going to select the top one. This results in 30 plus y equals 6, so I subtract 30 from each side, and I get y equals negative 24. So the point at which these two lines would intersect would be the point 10, negative 24. Let's do another practice one. Take a look at these. Again, I think the easiest scenario is to multiply to eliminate the y's. Because the coefficient on the top one is 1, the least common multiple of 1 and 5 would be 5. I'm going to multiply this top equation by 5 in order to create opposite terms. This results in 10x plus 5y equals 55. I will recopy the bottom equation, and now I'm going to stack and add them. 10x and 3x is 13x. 5y and negative 5y are opposites, so that's 0. They are eliminated. And 55 and 10 is 65. I have a simple one-step equation. I'm going to divide both sides by 13 to get x equals 5. I just need my y value. I'm going to substitute into either equation to get that. I'm choosing my top one. So it will be 2 times 5 plus y equals 11, or 10 plus y equals 11. Subtract 10 from each side, and I see that y equals positive 1. Again, I could verify this by graphing both lines. I could also substitute 5, 1 into both equations and make sure that it satisfies it. In this next practice problem, it's not as obvious how to create a pair of opposites. I can't just multiply one of my equations by something to do that, or I would introduce decimals. So I'm going to look at the x's this time. I've got 5x and 2x. The least common multiple of 5 and 2 would be 10. So I'm going to multiply this top equation by 2, and the bottom one not just by 5, but by negative 5, so that I create 10x and negative 10x as my pair of opposite terms. Carefully check your multiplication and your signs as you do your multiplication, because one wrong sign will cause